as I was saying, sorry that they interrupted. A call came in and I forgot to put it in airplane mode. But what I was saying is that there is no initial point. Rather, we just have a base to a power. Okay, and so basically it means that if I have 4 to the 0, you know that anything to the power of 0 is equals to 1. So 0, my first point will be at 1. 4 to the first power, right? If x is 1, then the y will be 4 to the 1 is 4. So about here. 4 to the second power, that would be 4 times 4, which is 16. So about, and again, this is just a sketch. It's not perfect, but we don't want to do like 4 in here and then 16 in here and then 32 in here, right? We don't want to do them too close because we want to do a good sketch. And then to the third power, 4 times 4 is 16 times 4 will be 64. So again, it's not very accurate, but I'm just going to put it in here. Of course, it would be a little farther. Okay, and so my graph is something like that. Okay, now remember that this converges to the asymptote 0. Now, I should say that that's my number 6. My number 7 will be y equals 4 to the negative x. And if you recall from previous lessons, a negative means a mirror. And it depends on, before we used to say if the negative is outside of the parentheses of the square root or the absolute value bars, then if it's outside, the mirror is horizontal. If it's inside of the parentheses or the square root or the absolute value bars, if it's inside the negative, then the mirror is vertical. Okay, in here, if the exponent is negative, where can I write the, if the exponent is negative, then the y-axis is the mirror. So it's the same idea, but it's just remembering inside outside. In here is if the negative is with the exponent, and then number 8 will be if the negative is with the base. Okay, so when the exponent is the one that is negative, then my mirror will be this. So anything to the right will be on the left, and anything on the left will be on the right. Okay, so let's see, let me use this color. So if this is my mirror, this will reflect right here. This point will reflect on this side. This point will reflect on this side. This is right on the mirror, so it stays where it is. And this little tail will reflect on this side. Okay, so again, that's when the exponent is negative. Now, what if y equals negative 4x? Whoops, not negative 4x, negative 4 to the x power. Now, in here, what is negative is the base. And so basically, what is being reflected is the original, okay? Not this one, but the original, this one right here. So this original one is going to be reflecting on the x-axis. So let me put a note. If the base is negative, then the x-axis is the mirror. Okay, what's a trick that I usually like to use tricks to remember, kind of like hints. Y-axis, that's when the exponent is the one above, okay, of the two. The base is below, the exponent is up above. Then if the negative is on the up above, then up and down is your mirror. If the negative is down below, then right here is your mirror, down below, okay? And so basically your reflection goes down below as well. Okay, so let me use this color now. It looks like aqua, some people call it blue. And so this point will reflect, remember this is the mirror, so it's gonna be around here. This will reflect around here. Let me extend the y-axis a little bit more. This point will reflect around here, and then the last one will be around here. And this part will be over here, because this is the reflection on this mirror, so right here. Okay, so don't let this other one confuse you, because this is the reflection of this original one. Okay, this is the two that are reflecting for for number 8, because the base is reflecting on the y-axis. Oh my goodness, on the x-axis. Okay, when the exponent is negative, the reflecting line is the y-axis. Okay, and this is my original, which is this equation right here. Almost there. Now let's do y equals 64 times 1/4 to the x power. In this case, we do have an initial point. We have a base which tells me what to do every cycle. And so in here we just have to kind of like be open-minded and apply what we have learned before. So what I'm going to do is just start. My initial point is a 64, and I know that because this is a fraction, it's going to go down, it's going to decline, it's a decay. Okay, let's say that we start with 64, and it can even be money, and every cycle you end up with only 1/4 of what you start with. Okay, so I start with $64, but every week I end up with only 1/4 of what I have. So after 1 week, so that's what I have right now. After 1 week, I have 1/4 of that, so that means I only have $16. So 1/4, this is 1/2, this is 1/4 about here. Okay, 1/4 is 1/2 of 1/2. So half of 64 is about here. Half of that, which is 32, is here, which is $16. Okay, so after 1, I have 16. After that, you know what, I'll expand it a little bit more since I'm doing decline so that it can show a little bit more. So maybe I'll put it in here. So 16. The second cycle, or the second week, I will have 1/4 of that, meaning that I only have half of half. So in here, and that will be equal to $4. Okay. On the third week, I'm going to have 1/4 of that, which is half of half, which is 1. After that, half of the half. After that, and it will continue, but it will never get to 0 unless it's protons, because they eventually disappear. Okay, this is my initial point. It tells me that every cycle I'm going to have 1/4 of that, and so that's why it's declining. Okay, and with money, of course, we can say that we can have 1/4 of a penny. So I don't know how we would go about that. Okay, so that's for number 8. What if I have 64 times 1/4 to the x minus 6? So this again will be similar to when you add or subtract on the exponent, you go left or right. Okay, in this case, you're subtracting, you don't go to the left, you go to the right. Remember, that is the opposite. And so I'm going to do this with this color, and just to remind me, if it's a minus on the exponent, then go to the right. And that's for every point. Okay, every point goes 6 spaces to the right. So this one is going to be about here. This one is going to be about here. This one is going to be about here. And then from there, you're going to continue to decrease and decrease and decrease. Okay? Until you eventually get super close to the 0, because you're converging to the asymptote 0. Okay, so you're now ready to do 8.13. Maybe I should give you an example where you would go up and down. So basically, if you just add, let's say you add 2 to all of it, all you do is go up. So I think I'll just leave it at that. Okay, but if you add or subtract to the exponent, you go right if it's minus, left if it's plus, down if you're adding to the whole function. What did I say? Up if you're, no, sorry, up if you're adding to the whole function, and down if you're subtracting to the whole function. Okay, so have fun. You can now do 8.13.